If you have a passing familiarity with the liberal arts, you have probably heard of the brothers Karamazov, the last novel by Fyodor Dostoevsky, who died months after it was published. It is widely considered one of the greatest pieces of literature ever written, touching on themes of atheism and religion, free will and responsibility, judgment, redemption, evil, suffering, love, and reason. But since I only got a couple chapters in before I put it down, with a hope to return to it someday, I will not be talking about the brothers Karamazov. If you have a passing familiarity with statistics, physics, or computer science, you have probably heard of the works of one of the brothers Ruskal, three mathematicians from the mid-20th century named William, Martin, and Joseph. Before I started work on this video, I had seen the name Ruskal mentioned in those different contexts of lecture notes and YouTube videos, but I never connected the dots. At best, I thought that maybe the physicist was also the computer scientist, a remnant of a time where it might still have been possible to contribute significantly to multiple fields. Today I hope to introduce you briefly to each of the brothers, and some of the work that they did with their name attached to it, sharing additional videos if you wanted to learn more about their ideas. Their biographies begin with their parents, Lillian and Joseph Bernard Ruskal. Both were Jewish, meeting in New York City, probably through connections that they both had to the fur trade, with Mr. Ruskal owning a wholesale fur firm with his brother. The family lived in New Rochelle, New York after their marriage on October 11, 1918. They eventually divorced, and following Joseph's death in 1949, Lillian remarried in 1954 to become Lillian Oppenheimer, and a few years later we get into origami, helping to popularize the term origami over the more common term paper folding used at the time. She would publish 5 books on the topic before her death in 1992 at the age of 93. William Henry Ruskal, born in 1919, was the eldest of the 5 Ruskal children. He received his bachelor's and master's in mathematics from Harvard in 1940 and 1941 respectively. Seeing the upcoming war in the future, he joined the war effort working with the U.S. Navy, first as a civilian and then getting a commission, developing an interest in statistics that he would carry through his post-naval career, which ended in 1946. He spent some time working for the family at the Ruskal & Ruskal Fur Firm before heading to Columbia in 1948, and then to Chicago in 1950. He eventually earned his Ph.D. in 1955, but after becoming an assistant professor at Chicago following his 1952 work on the analysis of variance with his boss Alan Wallace, founder of Chicago's statistics department. He would then rise the ranks at Chicago, becoming a distinguished professor in 1973 and retiring in 1990, joining and running high-ranking committees and organizations, editing prestigious journals, and named as a fellow of several statistical societies. He died in 2005 at the age of 85. The Ruskal-Wallace test, developed in 1952, is a non-parametric statistical test to determine whether a sample originates from the same distribution. Given n pieces of single-number data from G groups, indexed by I, these numbers are collectively ranked, with the number of their rank assigned to each member, denoted Rij. Ranks are uniformly distributed in case of ties, so if the 5th through 8th highest data points are all tied, they are assigned the average rank of 6.5. From there, we find the average rank of each group, R sub I, and then the average rank of all the data, R, and plug it into this formula to compute H, the test statistic. If the groups are large enough, the distribution of H is approximately a chi-squared distribution with G-1 degrees of freedom, from which one can compute a critical value H sub C. Exceeding this value indicates that at least one group stochastically dominates another, which roughly means that one cumulative distribution function is greater than the other. However, it does not say which pairs have a stochastic dominance relation. Other tests are needed to clarify that. It is a popular test, with implementations in many common statistical packages. If you want to compute the Ruskal-Wallace test, Data tab has a video explaining the test and how to compute it using their tool, link in the description. After William were 2 sisters, Molly and Rosalie, born in 1921 and 1923 respectively. I couldn't find too much about them, but at age 7 we know that Molly fell ill with meningitis, during which time she and her mother were first introduced into paper folding, contributing to her mother's later career. Rosalie seems to have died in 2008, as Molly had in 1978, but these numbers are hard to confirm. Martin David Ruskal was born in 1925. He graduated from Chicago in 1945 and was invited to join a famous researcher who also lived in New Rochelle. Richard Caron, at his new institution within NYU. This is now the famous Caron Institute. Martin earned his master's in 1948 and his Ph.D. in 1952 under the supervision of Caron. Ruskal then joined the plasma physics group at Princeton, but during his time he also contributed to the field of general relativity. In plasma physics, he developed much of the underlying theory of integrable systems and equations, an example of an integrable equation being the S-tier quarter-weight de Vries equation. Of the three brothers, he probably had the biggest career, culminating in his 1993 win of the President's National Medal, and I quote, "for his influence as a leader in nonlinear science for more than 2 decades as the principal architect of the theory of soliton solutions of nonlinear equations of evolution." Martin and his wife Laura also had a noted interest in origami, where she wrote a few books on the topic. Martin would die in 2006 at the age of 81. The Ruskal-Sheshkers coordinates, named for Martin and for George Sheshkers, are a coordinate system for a static black hole, described by the Schwarzschild metric. The original Schwarzschild metric has a singularity at the event horizon, called the coordinate singularity. This singularity is not physically real, and Ruskal-Sheshkers presents a coordinate system which does not have that. There are 2 main versions. The first keeps the axes aligned with time and distance, and the other aligns the axes to the light cone. These tricks make it easy to follow what happens as something travels into a black hole. The consequence of the coordinate system is that it easily allows space-time to extend into 4 regimes: our universe, the black hole, a white hole, and a parallel universe. This setup can be presented in a diamond shape, known as a Penrose diagram, which can then be built out to describe the full space of more complicated black holes, leading to many of the ideas presented about the makeup of our universe. While his academic career was strongly built on his work of integrable PDEs, the coordinates are probably his most famous contribution with his name on it, probably because black holes are more popular than plasma physics to a general audience. If you want to learn more about the coordinates, I would recommend Ike Chris's video on the topic, link in the description. Joseph Bernard Ruskal Jr. was born in 1928. While growing up, it is reported that his older brother Martin spent time with Joseph to teach him mathematics. Joseph received a bachelor's and master's from Chicago in 1948 and 1949, then went to Princeton to research for a Ph.D. His dissertation on well-partially ordered sets was finished in 1954, the problem supposedly coming out of a discussion that he had with Paul Erdős, eventually becoming Ruskal's tree theorem, which spawned the famous tree functions, whose values for small integers are 1, 3, and insanely large, but finite. In 1956, while still at Princeton, he published a paper on the shortest spanning subtree of a graph, developing what we now know as Ruskal's algorithm. After 3 years at Wisconsin-Madison, he ended up at Bell Labs in 1959, where he stayed until his retirement in 1993. Joseph died in 2010 at the age of 82. Ruskal's algorithm finds a minimum spanning tree in an undirected, edge-weighted graph, or the set of edges of smallest value, without any cycles. It starts by having all points disconnected, then taking the list of all the edges and sorting them by weight. It then takes the smallest edge and includes it to the tree if it does not form a cycle. It is a greedy algorithm for solving this problem, with the bottleneck of sorting edges by the weight. If you were to solve this problem by hand, you would probably intuitively choose Ruskal's algorithm. If you want a really cool explanation of it, I would check out the video by one Clyde Ruskal, professor of computer science and the son of Martin Ruskal, link in the description. Of the 3 Ruskal ideas that I've explained, the Ruskal algorithm is probably the most widely taught formally, happening in the 2nd or 3rd year of computer science programs, which is about 10 times as many students than those in statistics programs, who might learn the Ruskal test in the 3rd or 4th year. And that dwarfs those taught the Ruskal coordinates, taught to early graduate students in physics. The only other family of mathematicians that are probably more widely taught than the brothers Ruskal probably are the Bernoullis, and the only other family in science that might be more famous than them are the Curies. If you can think of another family of nameable mathematicians, I would love to hear them in the comments, and who knows, I could make a video about them in the future. If you like this video, then like this video. Thank you for watching.